Hello and welcome to another episode of EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in sustainability, climate change, buildings, and urban efficiency. I'm Vic Marinich, Global Marketing Director for Danfoss, and I'm delighted to be the host of this podcast. You can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever you get your podcasts. Today, we have Kent Peterson from P2S on the show to talk about decarbonization in buildings and embodied carbon. Ken is the Vice President and COO of P2S, an engineering, commissioning, and construction management firm. Kent, it's an honor to have you on the show.
Thank you, Vic.
Maybe to kick things off, can you tell our listeners a little bit about your background and how you got involved in sustainability and building design?
Absolutely. Well, first, let me thank you and say I'm honored to participate in your podcast today. And I want to thank you for bringing this important topic to your listeners. At P2S, I'm lucky to work with a group of passionate engineers that really care about our impact on the environment. I provide the lead to the engineering practices and try and provide inspiration and technical direction for all of our engineering staff. I've also donated extensive time in my career to help advance energy efficiency and sustainability in our industry. I served as the ASHRAE International President in 2007 and 2008, and I currently chair the ASHRAE Building Decarbonization Task Force, and I co-chair the GSA Federal Building Decarbonization Task Group.
Wow, so definitely have quite the track record there. When we talk about reducing carbon footprint in buildings, and a lot of our previous podcasts have kind of focused on the emissions from HVACR, right? Whether it's energy consumption or even the gases themselves, refrigerants used in the systems. But I think there's a lot more that we need to think about. Can you maybe talk to us about embodied carbon and how that differs from operational carbon?
Absolutely. Let me first start by saying when we talk about carbon, we're really talking about CO2 equivalent emissions. So in this podcast today, we'll use that term carbon, but we're always really talking about CO2 equivalent emissions when we use carbon. Operational carbon, most people are very familiar with. It's usually generated by the fuel that's consumed from heating and cooling, supplying fresh water, ventilation, or the power that goes to a building over the building's lifetime. When we get into embodied carbon, it's quite different. It's basically all other carbon emissions, and people don't really think about these things, but it's the emissions from manufacturing, from transportation, installation, maintenance, disposal of the construction materials used in the buildings. The upfront embodied carbon really refers to the greenhouse gas emissions that are released before the building or the infrastructure even starts to be used, which are largely from manufacturing impacts that are there. There's also a term that's being thrown around in the industry, total carbon or whole life carbon, and that's simply the sum of the two. So you take the operational carbon and the embodied carbon and add it together, and that would be the whole life carbon.
So when we look at the whole life carbon, I mean, why is it important to pay attention to the embodied carbon portion, and what are some of the sources of emissions that building owners or construction companies maybe don't think about?
That's a great question. Buildings really are responsible for roughly 40% of the global carbon emissions in the world. So according to the World Green Building Council, upfront carbon emissions are responsible for about half of the entire footprint of new construction between now and the year 2050. The building sector is one of the largest consumers of raw materials and products of waste in the United States. When we think about production of building materials, it accounts for a significant portion, usually 25% of the total energy or 75% of the raw materials consumed in the U.S. manufacturing industry. And as such, a circular economy for building materials stands to offer really significant gains for efficiency, waste reduction, and decarbonization. Just three materials that are really used in buildings, concrete, steel, and aluminum, are responsible for 23% of the total global emissions. And most of those materials, as I say, are used in the built environment. There's really an incredible opportunity, I believe, for embodied carbon reduction in these high impact materials through design, material selection, and specification of low carbon type materials. Another example would be renovating an existing building versus tearing it down and building a new can save somewhere between 50 and 75% of the upfront embodied carbon, just by an owner making that decision to renovate the building versus tearing it down and building new. The last thing, for the HVAC engineers out there is the emissions related to refrigerants are also considered to be embodied carbon emissions.
Yeah, you brought up a good point about retrofitting versus decommissioning the buildings, right? I mean, when we look at the building life cycle, we've got some different phases there, right? From everything from the design to the decommissioning. What kind of steps can we take at all these different phases to reduce embodied carbon emissions?
Well, let's talk about the building life cycle. So we have basically 5 building life cycle stages. We have the product life cycle stage, the construction, the maintain and use, which is pretty much throughout most of the life of the building, the end of life when we get to the end of the building, and then we have what we call the last cycle, which is beyond the life cycle, where we tend to decide whether we're going to recycle the components that come out of that building and reuse it for something else. And case studies really indicate that somewhere between 24 and 46% of embodied carbon savings can be realized at 1% or less of the construction cost. So this isn't a big cost upfront item in order to do this. It really just takes the process during the design stage of making the proper decisions of what we're going to do to use less embodied carbon in the construction. So material solutions could include optimizing our concrete mixes, using high recycled steel content, selecting low embodied carbon insulation products, selecting low embodied carbon glazing products, or even selecting low GWP refrigerants and minimizing the leakage of those refrigerants. There's some solutions on the method side, such as reusing materials, designing for longer life so we don't have to replace the systems as often, and designing for disassembly and considering how these materials might be disassembled so they can be reused for some future use. We can also reduce refrigerant emissions by reducing the refrigerant need. That could include by efficiency measures to make smaller refrigeration systems that go into buildings, whether it happen to be for heating or cooling, using the low GWP refrigerants, mitigating the leakage, and improving refrigerant recovery.
We talked about the building life cycle analysis. How does that differ from the life cycle cost analysis?
This is a great question because it's often confused in the industry, and most of us are very familiar with what we call LCCA, or life cycle cost analysis. And that's really just an economic evaluation technique that determines the total cost of owning and operating, whether it's a facility or a system within that facility over a period of time, to kind of say what makes the most economic sense of a system selection. What we're now being faced with is a life cycle assessment, or an LCA, that's starting to be used in the industry. And this is a methodology for assessing environmental impacts associated with all the stages we just talked about of the life cycle of a building. So if we wanted to take just the environmental impact of, say, carbon over the life of the facility, that LCA is a rapidly evolving science that illuminates some of these impacts in terms of the quality, severity, and duration of carbon. So a building generates these impacts over its entire life cycle. And there's several tools that are currently out in the marketplace. I mean, Tally, OneClick, Athena are some of the examples that are there. And these assessments are usually done in the early stages of the building design, so someone can make the proper selections of the types of materials that are going to be going into the building. Look at the trade-offs over the life of the building to trade off both embodied carbon and operational carbon to come up with the best total carbon analysis.
So you mentioned that these efforts are done in the early stages and we're looking at trade-offs and so on. So if you're the owner of an existing building, I don't know, I mean, it sounds maybe there's really nothing that we can do about embodied carbon. Is that right? Or is there something you can do if you've got an existing building still?
Another really good question. There's a lot of confusion in the industry regarding it. So I would say that's not really correct, that an existing building owner should not be interested in embodied carbon. As we talked about earlier, existing building owners will renew or upgrade or expand their buildings throughout the building life cycle. And so some of the items we discussed for new buildings also apply to existing buildings. If I'm renovating a building and I'm selecting my insulation, or I'm changing the windows in the building, I can go with low carbon solutions that might be there. If I'm expanding the building, I can look at what types of solutions would have the low carbon impacts from an embodied carbon standpoint. So I have these type of options in an existing building owner to really have an impact on embodied carbon. But it is also true that existing buildings have tremendous opportunities for reductions in operational carbon, especially the inefficient buildings that are out there. And some of the primary means for reducing operational carbon emissions are reducing the building energy use through energy efficiency retrofits, energy efficient electrification, using heat pumps of some of the building energy needs that are currently using fossil fuels, designing the buildings to optimize some of the grid flexibility that might be out there, when we can actually have times of the day where we have low carbon energy available on the grid, so we can use that storage that might be there. And providing on-site renewable energy is another thing, that if there happen to be in a grid area that doesn't have low carbon energy available from an electricity standpoint, they can provide on-site renewable energy to help lower their carbon footprint for the electricity that they're using.
So it sounds like we really focus on the embodied carbon early in the beginning stages, and then we work to minimize that as we're making some upgrades to the building. But then really, once the building is in operation, that it's the operational carbon that we should be focusing on and worrying about, right? Because that's something we can address day to day, right?
Very true.
So while we're talking about reducing carbon emissions for building, right, we know we're going to have an explosion of population growth coming forward, right, up to 24% globally, it sounds like, over the next 30 years. How do you see this impacting the building market, right? What kind of implications does this growth have on the building market and carbon emissions?
It certainly makes our task of decarbonizing the built environment a lot more challenging. Between now and 2050, the world population expected to increase by almost 2 billion people. So by 2050, 7 billion people are projected to live in urban areas. And to do this, that means that the global building stock area is expected to double by the year 2060. So that's in the next 40 years, it's going to double. So carbon emissions would be more than double if we did not change the way that buildings are currently built and how we use energy in buildings today. Right now, over 130 countries, and I think we're now up to over 10,000 cities in the world have committed to net zero emission economies by 2050. So the building industry is going to need to move all new and existing assets to net zero greenhouse gas emissions across their whole life cycle by the year 2050. So this is a heavy lift for our industry.
Yeah, right. 2050 is not that far down the road by now. Absolutely. So we're talking about reducing carbon emissions, and that usually goes hand in hand with energy efficiency. You mentioned earlier, right, that about 40% of the carbon emissions today come from commercial buildings. And we've talked about operational carbon versus embodied carbon, but is there some overlap? Like, what kind of role does energy efficiency play in reducing embodied carbon? And what kind of technologies do we need to increase that efficiency in buildings?
So, I mean, there's no question when we look at decarbonization, energy efficiency is number one in the loading order for reducing operational carbon emissions. And we think about replacement MEP systems in buildings when we need to replace them. Energy efficiency can also reduce the embodied carbon that's embedded in those MEP systems that we need to replace. So if we can do things on building envelopes to reduce the size of the systems that go in those buildings, we're having an impact on being able to reduce the embodied carbon on the MEP systems by using less resources and less refrigerants in those systems. So it's kind of a double win on the operational carbon side and the embodied carbon side. Efficient building envelopes and energy recovery technologies are really good examples of energy efficient strategies that allow us smaller systems in buildings. Heat pump technology is an energy efficiency strategy that allows for efficient electrification of the heating and cooling loads that are going to be in the buildings. And then sometimes we forget about things like control systems, but control systems integrated in the buildings can really help coordinate the supply and demand and shift some of the energy use. The demand side management systems can help save costs by optimizing use for when and where it's most needed. But also it can drive decarbonization by shifting energy use to times of the day when zero carbon energy is highest in the grid mix.
Right. So it really is looking at the whole picture. And maybe one quick point for clarification, just for everybody out there. You mentioned MEP a few times. Can you define that?
Talking about the mechanical, electrical, and plumbing systems that are in the buildings.
Perfect. Just making sure everybody's on the same page. So we know we've got our challenges in the U.S. that we're working towards, and we've seen the European Union moving forward with some things as well. And hopefully we can all learn from each other. One of the things that we're seeing in the European Union are these environmental product declarations, or EPDs. Do you see something like that coming in the U.S. as well?
Well, we're already moving in that direction in the United States. So in late 2021, the federal Buy Clean initiative started. And through the Buy Clean initiative, the federal government will, for the first time, prioritize the use of lower carbon construction materials in federal procurement and federally funded projects. Also, there's a Buy Clean California legislation that passed 3 years ago that requires all state projects to require EPDs on some of the major building construction materials, things like fenestration, concrete, and steel being used in buildings. And so this is already starting. I say it's starting because it's starting with the larger items, but it'll eventually move into the mechanical, the electrical, and the plumbing type items also as we start to move forward.
For sure. And I can tell you on the Danfoss side, we're seeing these requests coming from all over. Obviously, our customers are looking for EPDs because, right, they want to make sure the products they're including in their equipment are certified that way as well. So we've seen it coming in Europe. I don't know that I've had so many requests here in the U.S. yet, but for sure that's something that we see coming.
I would also like to point out that California just last month recently signed legislation, and it's referred to as AB 2446, and it's going to require life cycle assessments on projects over a certain size by the year 2025. So right now that size is over 10,000 square feet. So doing life cycle assessments is going to drive the requirements to get the EPDs in order to do those life cycle assessments.
That's good to hear. Talking also about some things I am seeing happening in Europe, they're also developing, they call their EBPD, or the European Buildings Performance Directive. So they're going beyond just looking at, setting efficiency ratings for individual pieces of equipment. And that I think we've all been used to seeing, right? But now they're also looking at the whole building envelope. And the regulations there in Europe are going to address both embodied carbon as well as operational carbon. Do you see something similar in that vein coming to the U.S.?
I do. The European Building Performance Directive is very important in terms of looking at building performance, and it addresses not only new buildings, but it addresses existing buildings. And that there's a real need out there for addressing existing buildings. Most of us know that our building energy codes address new buildings. What we don't do is we have no means currently to address existing buildings. So again, I believe that we're seeing some of this by the US federal government with the recent Inflation Reduction Act legislation and the federal Buy Clean initiative that's out there. The Inflation Reduction Act funded EPA to develop guidance on reducing embodied carbon and set aside roughly $2 billion for the General Service Administration to reduce embodied carbon in their construction of federal facilities. In the US, we have a term called building performance standards, and it's very similar to what's happening in Europe. Most people are familiar with the energy codes, as I mentioned earlier, that really impact new buildings or retrofitted buildings. But building performance standards is a different policy tool that allows us to address existing buildings. And several jurisdictions in the US have turned their attention to BPS policies that require building owners to meet performance targets by actively improving the building performance over time. And a building performance standards coalition was launched in January of this year by the White House and includes local jurisdictions that represent roughly 22% of the US population. And they intend right now to enact these BPS policies in their jurisdictions on or before Earth Day of 2024. So there's also other areas that are moving in the United States. ASHRAE is currently developing a whole life carbon design guide for MEP systems. Recent studies have shown that embodied carbon just from the mechanical, electrical, and plumbing systems can be between 15 and 49% of the total building embodied carbons, and even higher if the buildings are using photovoltaic systems for solar PV on the buildings themselves. There's also an effort underway right now by ASHRAE and the International Code Council to develop a new standard on evaluating greenhouse gas and carbon emissions in building design, construction, and operation that's going to provide a whole life carbon approach to support emission reductions in buildings. And this proposed standard will establish how to measure and verify greenhouse gas and carbon emissions over the building entire life cycle. The goal is to provide consistent procedures and data that can be referenced in policies and codes in the future. So I would not be surprised if we get 3 or 4 years down the road and we're going to start seeing more code requirements in our building codes regarding whole life carbon analysis, just like California is enacting in their legislation.
Yeah, for sure. That's, I think, things we need to see in the future. So I think there's a lot clearly that we know what needs to get done, right? There's a lot of, whether it's on embodied carbon, operational carbon. What do you see as some of the barriers that are keeping us from moving faster, whether it's on the operational or the embodied carbon side of things? And is it policies that we need? Is it incentives to the private sector? Or what do you think we need to do to really get that next step change going forward?
A little bit of everything you just mentioned.
Yeah.
I mean, there's no question from a challenge standpoint. The ability to scale up and train the current workforce are some of the largest challenges that we have. And when we talk about scalable solutions, there's a lot of existing buildings out there in our current building stock, and we need to be able to address the inefficiencies in those existing buildings and be able to electrify a lot of those buildings. existing buildings are a challenge. We need to find economical solutions that are viable to reduce carbon emissions across the existing building stock. And when it comes to economics, I believe money matters when considering, alternative investments that building owners make. So this is not something that has an open checkbook for trying to decarbonize. So we as an industry have to figure out how to economically retrofit these buildings and reduce the carbon emissions to get to some of the targets that are out there. Some minor challenges that we're currently facing in ASHRAE: cold climates definitely have more challenges than mild climates. We start to look at electrification options in these cold climates. Our electric grid supply is another challenge. It's going to have to move towards zero carbon emissions, and its infrastructure is going to have to keep up with the increasing electrical demands from transportation electrifying itself, in addition to buildings adding more electrification load that's going to be out there. As far as policies, we're going to begin to see building performance standards implemented by the jurisdictions in the United States. The new Inflation Reduction Act has some really good incentives for energy efficiency, renewable energy, and reducing carbon emissions. So that's on the incentive side. We're moving a little bit that way, at least on the federal tax structure, on getting some of those tax rebates. There's no question. We have challenges, but a lot of the agents, I would say, ASHRAE, AIA, U.S. Green Building Council, many of these people in the United States are all collaborating together. Urban Land Institute, BOMA. Everyone's kind of put their heads together and said, we understand what these challenges are. Let's work together to figure out how we can solve them together. And I have faith that we're going to come up with a lot of the solutions in the next few years here.
Mm-hmm. Great. And maybe just one last question. So do you see it really being more on the federal level? You mentioned cold climates are going to have one set of issues. Super warm, humid areas are going to have another set of issues when it comes to retrofitting. So do you think it can be addressed on the federal level, or do you think it's really going to be state by state, or again, all of the above?
It kind of brings me back to your question about the EU and the difference in the United States. And on the EU, they tend to operate at an EU level, and everything's different. In the United States, we tend to operate more at the local jurisdiction and moving its way up. The federal level tends to focus more on its own facilities, so federal facilities, and then maybe implementing policies that might have incentives through tax rebates and things to help the local jurisdictions. And even the Inflation Reduction Act put a lot of funds in there to help local jurisdictions improve their energy efficiency codes. So I think a lot of this is going to happen more at the local jurisdiction and the state jurisdiction level in the United States, because that's just the way we tend to operate. And it makes more sense because we have a lot of different climate zones in the United States, and having those local solutions for what applies to that local area is going to be a better solution in the long run.
Fantastic. Yeah, thanks, Kent. So that's it for this episode of EnVisioneering Exchange. I'd like to thank my guest, Kent Peterson, Vice President and COO of P2S, for joining us.
Thank you very much, Vic.
So don't forget to subscribe to EnVisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever you listen to podcasts. Lastly, if you enjoyed this episode, please don't forget to rate, review, and share with your network. Thanks for listening, and talk to you next time.
This podcast is for information purposes only. The views, information, or opinions expressed during the EnVisioneering Exchange podcast series are solely those of the individuals involved and not necessarily represent those of Danfoss LLC and its employees. Danfoss LLC is not responsible and does not verify for accuracy any of the information contained in the podcast series available for listening on this site. This podcast series does not constitute professional advice or services. This podcast, including Danfoss LLC and the producers, disclaim responsibility from any possible adverse effects of information contained herein. Opinions of guests are their own, and Danfoss LLC in this podcast does not endorse or accept responsibility of statements made by guests. This podcast does not make any representations or warranties about the guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. This podcast is available for private, non-commercial use only. You may not edit, modify, or redistribute this podcast. The developers of the EnVisioneering Exchange podcast site assume no liability for any activities in connection with this podcast or for use of this podcast in connection with any other website, computer, or playing device.